So what I have so far is this. I enter my method with this particular parameter, and it's going to be the number typed in by the user. Then I'm going to check the simple condition, get out immediately if it's true. And then I'm going to use this for loop to create a row or set of divisors which will grow incrementally. And eventually I will check for each divisor, and if the remainder of the division is 0, which means that there is an evenly divisible combination of the divisor and my candidate, then I need to get out and say, no, this is not a prime. So basically, this is here, this is not a prime. How about this? Let's test this code, right? I would advise that you've compiled it much earlier, but I came up with, this far. This far much code, so I'm just going to run it. Okay. Enter a number. Let me increase the size of it. And let's say, okay, 7. 7 is a prime. 8, not a prime. 9, not a prime. 11 is a prime, and so forth. So hopefully, probably, it seemed to be working okay. Enter 0 to exit 0. Okay, goodbye. I am thinking right now that this can be optimized a little bit. Let's see, if I start with 2, right, and start checking the values, start checking the values of my divisors. So my divisors really, inside this loop, my divisors grow like this. 2, 3, 4, 5, and so forth, right? Till I basically reach my candidate and stop. First observation, if this candidate is divisible by 2, what is going to happen? I am going to return false. Yes? No? Right? I'm sorry, divisible with the remainder 0, obviously. I'm going to exit. So therefore, I'm thinking that if it's divisible by 4, it is also divisible by 2. Agree? So maybe I can just say from this point on, I could test this condition separately, like do it this way, maybe. Do it this way, right? And say immediately, if it's divisible by 2, this is not a prime, divisible by 2. So that's one of the optimizations. Otherwise, I could say divisor equals 3. And then check my conditions and skip all other even numbers. So instead of saying 2, 3, 4, 5, rather check for 3. Don't need to check for 4, because that would be caught right here by the attempt to divide by 2, right? So maybe, how about 3, 5, 7, and so forth, 9, and so forth, okay? And other optimizations could be made, but maybe just one of the optimizations. So starting with 3 inside this loop and adding 2, keeping so basically we'll just say just check the odd numbers. Other optimizations can be made, but maybe this is just an example of an optimization. But I would like you to note that before I went to optimize and do some fancy things, I wanted to make sure that the very basic, almost stupid approach to solve this problem worked. And I would even, like, once I get some program to work, I typically immediately save it on the side. I make a copy of it, save someplace else, and just say, I have a working version of it. Then I can do my further improvements and modifications. And of course, this is endless. Like some artists go in to their studios and they work on their paintings for like 10 years. And many people walking into the studio would say this is a completely finished painting, but the artist thinks that it's still in the works, right? So is the code. It can be improved indefinitely. You can just spend all of your lifetime just thinking about how could I improve this program in terms of saving, using less memory or making it faster or using less operating system resources or anything. You can always improve. It's endless process. So, but again, once you have the working version, my advice is save it. Because sometimes you have to go back and examine what changed that it no longer works. So let's test this one, I guess, right? So, a little bit of an improvement, hopefully, in terms of less steps through the, the division. And by the way, speaking of the homework, you don't have to optimize. The very first version, which seemed to work, would suffice. So let's test this one real quick. All right. So enter number or 0. How about 7 is a prime? How about 2 is not a prime? How about 1? Not a prime. How about 19 is a prime? So hopefully, again, this is not exhaustive testing, but it could be tested compared to the known set of prime numbers within a particular range. Any other improvements anyone would suggest to say, okay, leave it alone, and that will be our version to determine if the number is prime? Anything else you think about? I'm thinking, if we have the candidate, yes, yeah, I'm sorry, I didn't see the hands. Yes, Sean.
You could take the square root of the candidate and just compare the square root to the divisor.
Mm-hmm. Correct. Yes, that method is there, but I wasn't planning to go that way. I think we can do it when we cover the math library. Thank you. And it's Cameron.
Ian.
Mm-hmm.
Is one considered prime or
No,
no? Not?
no. I think math defines prime as the lowest numbers too.
Okay.
Ah,
Just wondering.
so yeah, the improvement would be this. The divisor should probably never be greater than half of the candidate. Agree? Like, why would you want to check whether number 9 is prime and try to divide it by like 6 or 7 or 8? Doesn't make sense. We know it's not going to be divisible by any of those numbers. So perhaps this is yet another improvement. Just make sure that when we do our comparison, we divide the candidate by 2. Okay? So that's just, I think that instead of saying the divisor should be less than the candidate, say divisor should be less than half of the candidate. Right? Again, remains to be tested, but hopefully it's the right direction. So, but I truly appreciate your input about the square root. Of course, that type of method does exist. Another improvements that do exist is that instead of executing divisions by the divisor, most programs that actually do try to work with, working with prime numbers and determining them, instead they store an array of already computed prime numbers, and instead of sort of like inventing divisors on the fly by themselves, instead they go through already stored prime numbers and divide by them. That's faster. Because if you already computed the number, you store it in memory. Yes, you use more memory that way, but that way you don't have to execute math, and division is maybe an expensive operation. So especially when the number is big, so it's could be another improvement. Okay, I would like to save this portion.